Are you ready to talk about graphs? So we talked about speed. Just so you know, on my side, my little video of my face down in the bottom corner is just sitting here. It's black and it's spinning. It's trying. I've gave it a ton of time to see if it would come up, but it's not coming up. So we're just going to roll with it. If my face pops up, we'll know that it's just finally started working. Anyway, so distance time graphs, also known as motion graphs, but we call them distance time graphs. So we've talked about speed, we calculated speeds, you all know exactly how to do that. Now we're going to talk about speed and how we can put it into a graph. So let's go over this paper right here. So describing the motion of an object is occasionally hard to do with words. Sometimes we use graphs to help make motion easier to picture and therefore understand. So there's a couple things to remember. Motion is a change in position measured by distance and time. Speed tells us the rate at which an object moves. Velocity tells us the speed and direction of a moving object. And acceleration tells us the rate, speed, or direction things change. Okay? So distance time graphs. When we plot a distance against time, you can tell a lot about the motion. So let's look at the axis. Remember whenever we talked about the two different axes? We've got x-axis, that's the horizontal one. Remember, that's the one where we looked out the window and we saw the horizon line where the sky meets the trees. So we know horizon and horizontal, they sound a lot alike, and they live on the x-axis, okay? So time is going to be plotted on the x-axis, and that's the one at the bottom that goes side to side. The further right on the axis, so the further this way, the longer the time from the start. So you're going to start time right here, so that would be 0 most of the time. And then the further you get away from the axis, the longer your time is going to go. And it might be minutes here, might be seconds, could be hours. It'll tell you right here at the bottom which it is, okay? So now the distance is going to be plotted on the y-axis. And the way I remember the y-axis, so horizon, if you look at that X right there, it doesn't really have anything that goes side to side. They're both on angles. But the y-axis is always going to be up and down, and I look right there on that y, and that tells me that's going to be up and down. Up and down is vertical. Okay, so the distance is going to be plotted on this y-axis, so that's this up and down one right here, okay? The higher up on this graph, the further you'll be from the start. So right here, you're going to be 0. That's where you start, okay? So the higher up you go, the further from start you're going to be. Does that make sense? Okay, so depending on the distance, the unit, that will be right here. They'll always write that right there for you, whether it's a centimeter, a meter, a kilometer, a mile, whatever that's going to be, they'll tell you right there, okay? So let's scoot down a little bit. We've got, if an object is moving, a horizontal line is shown on the distance time graph. I'm sorry, if an object is not moving. Okay, if an object is not moving, it'll show up just like this right here as a straight horizontal line on the line graph. So the time keeps moving. See how the time keeps moving? You know it's still moving because your line comes all the way to right here, but the distance does not change. So your distance right here doesn't go up and down. It's not moving at all. So we say this horizontal line, that's at rest, okay? So when we're reading these distance time graphs, if you see a spot that's got a horizontal line like this right here, that's where it'll be at rest, okay? So I'm going to flip our note page over here. The next part talks about constant speed, okay? So if an object is moving at a constant speed, it means that it has the same increase in distance in any given time. So time is increasing to the right and distance is increasing constantly with the time, consistently. So the object moves at a constant speed. So constant speed on a graph is always going to be shown just like this right here. So it's going to be a constant diagonal line. So see how this is diagonal? It's not horizontal. It's not up and down. It's at a diagonal. So that's going to be a constant speed, okay? So this is going to be important things for you to know. That diagonal will be at constant speed, okay? So here we're going to look at two moving objects. Both of the lines on this graph show that an object moved the same distance, and we know that because if we come up here and bring our line across, they both ended up at the right place, right? So that's the same distance from start, but they got there at different times. So this dashed line got there faster than this straight line right here. We know that because if we look at the time, there's that time, okay, that's about that far from start. Well, this time is all the way over here towards the end. So we can say this dashed line, we know just by looking at it, was moving faster than this line right here. So the steeper the line, the faster something is moving, okay? So the steeper the line, see how almost up and down it is right there? The faster it moves, okay? The closer to horizontal the line is, the least steep, it's going to be moving a little bit slower, okay? We can also look at this graph. That's a straight line at a diagonal. That's a straight line at a diagonal. So both of these are constant speeds. We know that because they're both straight diagonal lines, okay? So there's already a bunch of stuff we can see just on a distance time graph, okay? So this one right here looks a little bit different. It's kind of got a little whoop in it right there, okay? So what this means is that's acceleration. So graphs that show acceleration look different from those that show constant speed. The line on this graph is curving upwards right here, okay? This shows an increase in speed when it's curving upwards like this. That means that it's going faster. So say if we were at a stop sign, and we took off from the stop sign, this might be what our graph would look like because we started out, stopped, and then we got faster and faster and faster as we took off, okay? Does that kind of make sense a little bit? It might be opposite if we were slowing down, but this curved line is going to show acceleration. That's one of our vocabulary words, okay? So let's look at this graph right here. This one's got all kinds of information on it, and we're going to kind of check it out. So a distance time graph shows us how far an object moved with time. The steeper the line, the faster the motion. So this line right here is pretty steep. That's really close to being up and down. So we know that this was a fast, steady speed. It's a constant speed because it's a straight diagonal line, okay? A horizontal line means that an object is not changing position. It's not moving. It's at rest. So we can see that right here on this line right there. That is at rest, and we know that because that's that horizontal line. Remember the horizon, horizontal line, it matches up with this x-axis down here. That is at rest. A downward sloping line right here means like this one right here, see how it's going downwards? These ones are all going up, but this one's going down. That means that they're returning home. They're returning to the start. So if we look at this graph right here, just this one, we know we started from somewhere, and we're going to say we started from home, okay? So right here, we started from home, we left the house, we went at a constant speed, and say we had to stop at Joe Bob's for a gallon of milk, okay? So we left the house, we drove to Joe Bob's, we stopped. We parked in the parking lot. We run inside real quick. We're still parked in the parking lot. We're at the store, so we're at rest right here. We're not going anywhere. We get our milk, and then we come on back home. So here is what it looks like when we come back home. Kind of makes sense? So whenever you see them going down like that, know that that means we're going back home. We're going back to where we started from, okay? And then this line right here is that line that shows acceleration, okay? So this line right here says that we're getting faster. All right, well, I hope that helped a little bit understand distance and time graphs. We're going to have a couple graphs in the questions below, and I'm going to have you tell me about them, okay? We'll make sure that you watch the video at the end because we'll talk about them and make sure that you are in the right direction whenever we're talking about distance and time graphs, okay? Y'all are amazing, and